Hello everyone, welcome back to our tutorial series from ONELVXE Studios. Today we are going to be moving on to part 2 of the realistic lighting, shading, and texturing workflows within Blender 3D. In part 1 we created a physically based rendering setup that allowed us to generate realistic results within Blender 3D relatively quickly. Within about 30 minutes to an hour of using this workflow, you should be able to render out or preview render a good looking test image that has realistic properties and basically just looks decent enough for you to move on to part 2. So today we're going to be covering rendering settings and how to render within Blender. This is going to sort of be a look at how to best render still images, animations. We may cover some baking as well in this. And then once we get through that, we'll look at how to output your files. So what's the best format? And once we do that, we will move on to compositing and how to make your images sort of pop. That is the goal for today. So, with that in mind, let's drop into Blender and get going. So by now, I hope you familiarize yourself with our workflow setup. As I went through in the first video, we have about 10 screens here listed in your window. I'm sorry, this is the layout manager up here. We have about 10 screens that all serve different functions, and in the first video we went through free space, lighting, materials, and texturing. We're going to be skipping animation today and moving straight on to compositing. The compositing workflow I'm going to be showing you is relevant to animation, so if you do decide to take a still image and animate it, then this workflow will apply as well. So, with that being said, we already have our scene set up. I'm going to go ahead and switch to that now. So I hope you guys all remember Gorgon. He's back again. We've already textured him and given him shading, set up our image-based lighting. We're basically good to go. If I do a little preview render here, as you can see, I decided to default back to the original settings I had for this outer shell material. So I will drop into the node editor and show you that. I changed up the shading on the brain here and the underside, the base of the Gorgon model. And our image-based lighting is still in the background, providing us all our lights in our scene. As you can see over here in the outliner window, there are no lights. The only lighting that the scene is getting is from the default lighting setup here. That's controlled by this world shader node that I covered last time. So if we drop into let's go into materials, and I'll set back up the preview render so you can see. So all this world lighting is coming from this world shader over here. I dove into the node settings, kind of talked about how you have two different environment textures, how those textures basically give light to the scene, how to control them with either the settings over here or in the node editor itself. And then from there I went on to discuss how to create physically based shading for any model, or basically, yeah, any model essentially. So here we have a simple metallic material that has the color, the rim color, the IOR is left at default, roughness and normal values. All those values are being controlled by this texturing node over here. If we dive into that, we have our diffuse map, which is controlling the color, roughness map, which is controlling the color input, normal map, controlling the normal input, and the metallic map, which is providing nothing at this point. Since this is already a metallic material, it doesn't need the metallic map to perform any rendering calculations, or shading calculations, I should say. So, yeah, our material is set up. We're good here. On our brain material, I have essentially updated the main file, the startup file that I provided for y'all on the website. You can go to onelvxe.com, onelvxe.com/apply, and when you go to that site, you'll get some info on how to apply to our studio, join our studio, and sort of the tools that we use. And over here in the corner, or on the side over here, you have the Blender startup file. If you click that, it'll start the download for the Blender startup file. If you open that file, it gives you that same default setup that I have I am demonstrating here in our main, or in our tutorial scene. So the default lighting shader is in here. If you go down to the materials panel, you'll see this same workflow, this shading workflow setup. So I have framed out the texturing nodes. They're just over here kind of floating. You can move this frame and do as you wish with it. I have replaced or renamed this metallic input. It was causing some confusion yesterday because, in the last video, because if you plug in the metallic, specular metallic, or it was called metallic, texture input into the specular node down here, it doesn't do anything for this metallic material. Because of that, you would think, okay, let me plug this in and I'll get specular reflection on my metallic shader. Well, it doesn't work that way. This metallic shader has no specular input, while the dielectric material and the glass/reflection surfaces all have specular inputs. Metallic does not, but the dielectric, refraction, and reflection surfaces do. I've also done you a favor and renamed this to ONELVXE surface, just for branding purposes, that sort of thing. So down here I've also included some other cool setups. These are the group nodes themselves that are inside of this surface node. So I have isolated them over here so you can see them, gave them some cool colors, whatever. And so you've got the metallic, the dielectric, and glass surface materials. And over here you have the reflection node setup that has the custom Fresnel node sitting inside, courtesy of Cinecat Pro. In the last video I included a link to tutorials. I will also throw another one in here just for due service. And then over here I've included some cool experimental sort of materials that could be useful for you. This is a smoke material setup. I haven't really used it in a while, but it basically allows you to control the, here, let me expand it so you can see, control the scale of the smoke, so the contrast between the dark and light values of it, the density of the smoke, how thick it appears, the scattering and absorption color of the fire, of the smoke. And in here I have included a color ramp node that maps out fire for you. So these are the typical colors you'll find in fire. It looks good, it looks realistic, and you can control the settings for your fire if you're running a dynamic or a smoke simulation. You can control all the settings for your smoke and fire materials here. Beyond that, there's also the Xe Volumetric Shader sitting right here. You have two scatter colors you can mix between. And beyond that, there is an absorption and transparency color, emission strength, and scatter density. I'm not really going to get into too much detail on how these work. I think I got this from Jonathan Lampel. This is basically how the shader is set up. You are mixing between emission and transparency up here. You're controlling the volume shading down here. So if you were to use this node, you would plug the volume shader here into the volume output of your material output node, and you would plug the emission shader node into the top surface output. So the emission will emit a color and basically tell the surface what color to be, and the volume shader will color the inside of the material as if it was, as if there were light rays going inside of it. So it's a really cool shading node. Play around with it, see what kind of results you get. If you can improve it any, please post those improvements and let me know. It's like I said, it's very experimental. I haven't really done much with it. So anyway, we are going to go ahead and move on to the rendering settings. So I'm going to switch back now to our main scene over here, and we can start tackling that. One of the most talked about, or I should say, one of the most difficult aspects of Blender and cycles is how to get realistic looking images out of it. The settings really aren't all that intuitive. You have your material settings and your shading and texturing workflows over here. You have the image-based lighting, which creates a good effect, but when you're ready to actually go render it, I mean, you want it to come out crystal clear, perfect, with a low amount of noise, and as fast, you want to render it as fast as possible. So at this point, I'm going to start talking about how you can optimize your render settings to render out very quickly, give you a low amount of noise, and to look as real as possible. First thing we're going to talk about is over here in the material settings. So if you are doing any sort of materialing, texturing, whatever, you want to come down here into settings. So this is the properties window over here on the left. You can pop it open to give yourself a little bit more space. You want to come down here to settings, and you want to click multiple important sampling. I want to say that it does something really cool. It is basically written into the Blender code to optimize the way that light interacts with the surface of an object and the volume of an object. So basically it takes light input, let's say this light input back here, and it says, okay, this light is really only affecting this side of the material, so we're not going to worry about calculating the bounce rays that are bouncing from this side over to this side. We're just going to kind of leave those alone, and it prioritizes the lighting on this side for that specific area right there. So you want to turn this on. Most of the time you want to have multiple important samplings on. If you have a really, really big object, then as this little tooltip says right here, use multiple important sampling for this material. Disabling may reduce overall noise for large objects that emit little light compared to other light sources. So if you have a really, really big object, you may not want to use this, but for the most part, I typically have this on. Secondly, you want to, if you're going to do any volume rendering, so if you have your materials set up and you're using one of the volume shaders that I've provided, so for smoke simulations, for anything that gets plugged into this node here, this node output, you are going to want to click homogeneous for the most part. 90% of the time, if you're doing smoke or anything like that, you don't need to use heterogeneous sampling, which basically the render engine will calculate a specific voxel or point of smoke or whatever within your volume shader. It'll calculate a specific point, and then it'll step a little bit further inside of your mesh or inside of your volume shader and calculate another point or another pixel or voxel of light, and it'll continue stepping forward and forward and forward. You can see those heterogeneous settings here in volume sampling. So this controls the size, how far per sample that the rendering engine is going to calculate the next sample. So every 0.10 or 0.10 steps in between samples, it is going to calculate a new sample. And this over here, the max steps, tells it how many steps to calculate total. So if you want to avoid really long render times, you want to use smaller step sizes and smaller max steps. The problem with that, though, is that you start getting very unrealistic looking results really quickly, and these settings are kind of finicky. They don't really have set values per se, and they're just hard to approximate and get looking right. So if my material doesn't need to look, if my volume material doesn't need to look different all the way through or do anything crazy, it just needs to be a smoky looking volume shader, or, you know, emit some, if I'm doing a glass material and I want it to have a tinted inside portion, a tinted volume inside of it, then I typically will just do homogeneous because it renders a lot faster and doesn't have to do all those extra step calculations, and it takes the closest sample it can find and just applies that across all of the voxels within your volume. So those are two quick optimizations to help you out. From there, let's go over to the world panel. So you'll see the default lighting set up here, a little preview of our lighting background and that sort of thing. But you want to come down here to settings as well, and you'll want to check multiple important sampling if you're using world lighting. So as I said before, it's going to basically make this light over here more important for this side of the material than this side of the material. If anyone knows that what I'm saying is completely incorrect and I'm just messing this up badly, please comment and feel free to correct me, but that's how I understand that it works. So yeah. Beyond that, this is the map resolution size. So the larger your map resolution is, the more memory your computer is going to, or your graphics card or whatever is going to use to calculate the lighting. So a larger size will give you less noise, but it will take a little bit longer and will use up more memory. So if you're trying to conserve your memory, you have a 2 gigabit graphics card, or you don't have a lot of memory to spare in your scene and you're trying to get it to render fast, you can turn this value down. 1024 is a good place to start. I have it set at default at 2048 because my personal graphics card settings allow me to use a map size that large, and I never really have to worry about memory or speed. So that gives me the best lighting possible for the best return in terms of memory and speed. So I stick with that value. And then for max bounces, I stick with the maximum value, 1024. If you are trying to approximate, you know, if you're trying to render something faster, turn that down to half, like 512 or 256, etc. Blender really likes power of 2 values. So whenever you're doing anything with resolution, bounces, render tile sizing, which we'll get into later, you want to, or even texturing, use power of 2. It renders faster, it calculates faster. Blender and most 3D applications just have a much better time if you're using power of 2 values. So that's 128, 512, or 256, 512, 1024, 2048, 4096, 8192, 16 something something something. It just keeps going and going. So do that. We're going to come back to the color management settings over here and mess with those when we start getting into compositing. You also have this units function here, which could be useful if you're trying to get the scaling right on a model. Scaling is also one of those things that can kill your realism. If you have a really, really big ocean and a really, really, really big ship inside of that ocean, and they're not scaled correctly, then it's just not going to look right. So you want to make sure your scaling is all correct, and you can control your scaling values here. You've got the metric system, which puts it in meters and centimeters, and imperial, which is feet and all that stuff. I don't really know why America still uses imperial. Just, whatever. Another aside of mine. And continuing. Over here you have render passes in this panel, and so like I said, we'll talk about this a little bit more once we get into compositing. And with the camera icon here, you get into the main render settings for your scene. I'm going to go ahead and switch to the compositing window now, and let me switch back to our tutorial scene so you can see what's going on, because I really don't need the node setup anymore, or that I don't need that other setup. This kind of optimizes it for you. If I was to render this, like I will now, this over here, I have it set to image editor for the render output, and so the render result is going to show up over here. So it allows you to compare all your render settings and any compositing and stuff you may do with a viewer node over in this section of your screen with your live preview if you're doing both at the same time, or if your computer is powerful enough to do both at the same time. So I'm going to cancel that because, we're not even there yet. We'll get there. Right now, we're going to mainly focus on this tab over here. At the top, you'll see this render street icon. I was testing out or this render street panel. I was testing their render farm. It's expensive. It is finicky. It's not a bad service. It just, line render is a lot better. So I will be adding that back into the setup file so that anyone that decides to get a line render account, so they can use line render for rendering out animations or accelerating their still image rendering times, you can just put in your login information and all that and output directly to their render farm. They should have a plugin. I will have to check on that and make sure. If they don't, I will include instructions for how to upload to line render. So from there, you have your normal render settings. You can render out a still image whenever you press the F12 button. And I'm going to turn on screencast keys because I forgot to do that again. Where are you? Little dumb keys. That's the wrong thing. Okay. Bingo. Save those because I keep forgetting to turn them on. And okay. Good. Now you can see what I'm doing. I don't know if you can see what I'm doing up here. Don't know why it doesn't let me do that up here. Whoever wrote that thing, you're awesome for putting it in, but let me put it in up here too. Yeah, it's still a great thing though. So if you're watching a tutorial, you can see what keys I'm pressing and all. So if you press F12, back to the tutorial now. If you press F12, it is going to render with this button. And yeah, stop giving me Facebook notifications. Good Lord. It's going to basically press this button for you. So F12 is a shortcut to render, so you don't have to navigate back to this panel every time. You can also render on animation or audio. I haven't done audio rendering. I'm assuming that's using the video sequence editor, which looks like this. They're thinking about taking it out of Blender. I never use it. I use Nuke Studio and Adobe Premiere because I have an Adobe Creative Cloud subscription, and it's one of those things that I think is holding back normal Blender development and probably just needs to come out. Even though some people use it because it's free, I think it's time to move on and let people, figure out other solutions to the video sequencing problem, and focus on cooler things like a UI update or whatever else. Beyond that, you have the display for where you can render your image out to: full screen, image editor, new window, keep UI. So if you keep the UI, it'll just render the image and won't do anything to your screen at all. You won't even know it's rendering. There'll be a little status bar up here. That's about it. So down here, you can basically decide how you want to render your file out. I typically go 1920 by 1080, and if I'm doing a small test render, I will render at about 50%, or if it's a really heavy scene, even down to 30%, 25%, whatever. For this, I'm going to leave it at 100 because soon I'm going to render this image out so we can start compositing it. For frame rate, you typically want to be at 23.98 frames per second. There's a whole bunch of literature on that and a whole bunch of differing opinions on what you should use. If you're in America, use 23.98 because that is basically standard. And if you're working in another compositing application or video sequence application, then 23.98 is going to give you better frame. You won't get double frames. You won't get a bunch of extra crap if you're using that. Using 24, you'll run into some of those issues. 25, I believe, is European settings. And then 29.97 is the same thing to 30 frames per second as 23.98 is. So if you're rendering something out at 30 frames per second, it's usually going to be for like a video game that you're trying to get at maximum resolution, maximum render time, but not have to worry about frame rate issues, quickest render time, and not worry about frame rate issues. Or you have 60, which is what most video games try to run in these days. We're not really going to touch this, just leave it at that. The rest of these aren't important. This over here, frame range, just tells you how long, if you're doing an animation, to render frames for, where to start, that sort of thing. So metadata, if you want to stamp your images, you can. I don't use it. Yeah, whatever. Output is where your images will get output to. When you render an image in Blender, it saves it locally, meaning it really doesn't save it, it just buffers it onto your local relative Blender file. It's just kind of floating here. Until you press the F3 button to save the image, it is not saved. So if you render something and you like it, press F3 and save it somewhere. All of your temporary frames from animation, or all of your frames that you render out, will typically go to this temp folder. And you can set up a folder to render to here in File. Just go to Render Output, and it should usually send files directly to that bin for you. If not, I don't know. I'm going to have to come back and look at that, because I wasn't planning on talking about it, so I forgot. Whatever. Not that important, other than if you're going to do an animation, set this file path here to tell your computer where to put the frames at. Important if you're doing an animation. If not, it's just going to go to this temp folder, wherever that is. It's in the C drive here in temp, so stuff is there. Cool. This controls what file output you're going to render to. If you're rendering it, this is all of this in this output settings here is for animation. None of it is really important for rendering a still image. It's all mainly for animation. So, if you're doing a test render or anything just basic, you're not doing it for like a full production, you're not doing it for anything major, you're just kind of testing stuff out, use PNGs. They're light, they compress well, they're lossless, and you can get a floating depth of 16 bits. So they can cache a good, decent chunk of data. Cache, not cache. I just corrected myself. It's fine. There's also two other settings you should use or look at using. OpenEXR and OpenEXR Multilayer. So if you use OpenEXR, that is made by ILM. Those geniuses over there figured out a way to allow you to get 32 bits worth of information into a picture and save that information out to an image. So it can be used in other applications like Nuke or whatever, sequencing application you're using, like Adobe Premiere. So OpenEXRs are typically going to be the default thing that you want to render an animation out to. Go to OpenEXR. You're going to get the most data. You're going to have very heavy files. Your images might be 50 to 600 megabits each, but you're going to get the best looking images with OpenEXR. It's going to put it into a linear workspace, and it's all good. So use OpenEXR if you can. I would personally recommend using OpenEXR Multilayer. I have to check and make sure that Nuke Studio, which is our main compositing application, uses multilayer, can read multilayer files. I'm not sure if it can, but multilayer files basically, if you have different render layers, so you have an alpha channel, a Z channel, and you also decide to calculate an extra pass, so you want to get the ambient occlusion, you want to get the emission, subsurface scattering, glossy, diffuse, direct. If you check all of these here, they're going to show up in your render layer node over here in the compositing window. All of these nodes here basically are your passes. If you save your animation out to a OpenEXR multilayer, it's going to save all of these passes into the file as well. So instead of rendering out all these passes and then writing out each set of frames individually, it just does it all for you. So it's really, really useful if you are taking, say, a glossy pass and bringing up the glossy values and then compositing it back with your main image or your diffuse lighting, or you want to take out all of the ambient occlusion, or use the ambient occlusion to mask something off. It just makes it's awesome. So use that if you can. I would recommend using that. So that basically covers your animation output settings. get familiar with those if you're doing animation. And now we're going to move on to sampling. Sampling, this is freestyle up here. I'll just mention this real quick. This is for like toon rendering, and it gives you a line on the outside of your render. I never use it. I don't do non-physically based rendering in PR, so I just leave that alone. I never touch it. Down here is sampling. So sampling is where most of the confusion and most of the issues when it comes to rendering are going to come from. All the other settings we've talked about are just basic things that you can take care of and are going to change from scene to scene, but are very intuitive. Like it just makes sense. When it comes to sampling, light paths, and all the other settings that are within this render panel, it starts to get a little confusing. So we're going to break this down and make it really simple for you. First off, you have two integration options. You have the path tracing renderer, or you have branch path tracing. So path tracing is just going to calculate a light path. So this is my camera view right here, and light shoots out from the camera to the object. Blender, if you're using path tracing, is going to calculate one path here, and where that path terminates outside of the camera view. So it's going to bounce here, and then go out this way, and it may not bounce back, and so it'll terminate the light path. It just calculates one path, one single ray at a time. If you use branched path tracing, basically what that means is it's going to fire all different types of rays from the camera at the same time. So it's going to fire anti-aliased ray samples, it's going to fire diffuse rays, it's going to fire glossy rays, transmission rays, AO rays, mesh light, subsurface, and volume rays. It's going to calculate all these different types of lighting and shading data in your scene for you. Now, typically, you don't want to use this because it will slow you down and is slightly buggy. I don't know if they've fixed all the bugs with it yet, but it is really good for allowing you to kind of debug your scene and figure out what may be giving your image noise or making it look all grainy. So, for best results, I recommend turning the render settings up to about 6. So that means if you have square sampling on, which I'd recommend, between 6 and 8. You usually don't need to go above there. It's going to render 64 total samples just for the anti-alias sampling, just for the diffuse, glossy, transmission, all of these things. Okay? So it's going to calculate light. It's basically going to calculate the sampling for all of these things 64 times. So if you're not using branch path tracing, you'll see that it is going to, if I have this set to 6 here, it's just going to calculate, I started an animation for some reason. Sorry. It is just going to calculate 6 total rays, or 6 squared rays, so 36 anti-alias rays. And it's going to include the diffuse rays, the glossy rays, and all the other rays necessary into that one pass. So it averages it all out for you and makes it all look nice, and it is just usually a better way to do it. Blender Cycles is pretty smart about the way it does its path tracing. It's pretty fast, it's pretty accurate, and gives you good results out of the box, so you don't really need to do much debugging here. But if you do decide to try to figure out where your noise is coming from, you can individually tweak each one of these sampling settings here, so you can calculate one extra diffuse sample. So it's going to take your 8 samples, square it, and then multiply it. It's going to multiply it by the squared value here. So you got 8 samples squared, and that's 64. And then here, it's going to take this same number, so 8, and it's going to square it because you have square sampling on. And then it is going to square this diffuse value, so it's going to take 2 times 2, so that's 4, and then multiply 4 by 64. So you end up with 256 samples. If I turn this off, square sampling off, you'll see I'm getting 8 regular anti-alias samplings and 2 diffuse samplings. So for every 1 sample that I am calculating here, normal camera sample, I am also calculating 1 extra, so 2 diffuse samples. But typically I use square sampling on. It just makes life easier for artist control, and you don't have to worry about specific values and that sort of thing. And it's actually how most other rendering engines do it. I know Arnold Render uses squared sampling values as well. So It's good, just good practice. Anyway, so you can use these settings to basically debug your scene and calculate extra samples for a different pass. So if you notice that your mesh or the ground of your scene is really noisy, but the specular highlights aren't, you can turn up the diffuse samples and turn down the glossy samples, because you don't need as many samples to get a clear result for your glossy image if your glossy shading if your diffuse lighting is what's causing most of the noise in the image. So this allows for quick debugging and that sort of thing. Just a good workflow for you. I already covered volume sampling a little bit. If you turn on homogeneous sampling in the material or world panel, the world panel is specifically just for the world shader, not for every object in the world. And the material homogeneous setting is just for that material. So if you're using a volumetric world setup, then you want to click it for the world for sure. And I need to turn off these notifications. It's getting so annoying. Yes, it is my website, Brandon. You're not annoying. I'm just recording a video, but it's fine. So yeah, as I was saying, this controls the volume sampling for your your material. So if you want to change volume sampling, I would recommend doing it homogeneously, not heterogeneously. And now we are down to light paths and what this does. So I'm going to keep the light paths open and the sampling thing open so I can kind of talk about both at the same time. I already covered most of the sampling problems you may run into and gave you some tips on how to debug your scene and calculate where your noise is coming from. Now I'm going to talk about light paths. So light paths basically takes these sampling settings and applies it to your scene. So you're calculating a certain amount of samples, you're sampling your scene for, if you're doing branch path tracing, you're sampling your scene for diffuse, glossy, transmission, AO, all of those lights. Path tracing, regular path tracing is doing it automatically for you. You're calculating those samples, and this is saying how many total bounces you want the renderer to think about. How many total bounces do you want to be included in these samples? So the more bounces you have in your settings here, the more bounces that your rendering engine is going to calculate in each sample. What that means, in layman's terms, is that your renders are going to take a lot longer the higher these values are, especially the higher these values are. These values over here is going to scale it scales the time of rendering something pretty evenly. So it's very predictable, and it's not necessarily intuitive, but changing the sampling amount gives you predictable results. Changing the light paths without knowing what you're doing will mess everything up. So we're going to go through this, and I'll show you what to do here. For transparency, I typically leave these at 8 and just don't touch them, because you are usually not doing anything. You're not using transparency in most of your renders anyway, and beyond that, 8 is typically a good value for transparency. It's the total number of bounces that your render is going to calculate for transparent shading. So just leave that. It's not really something we're going to cover all that much. Shadows you typically want checked. And then here you get into Caustics. And Caustics is a cool, interesting light effect that happens when you have a reflective or a refractive material. Light bounces off of it and spills onto the ground around it or on the object itself. And what results are brighter images, or what result is a brighter image. I'll pull up the caustic effect so you can get a good idea of what I'm talking about. It's this. These super bright white shadowing effects here are caustics, and it happens when you have a curved, refracted or reflected surface. So typically, if you're not worried about render times, if saving render time isn't a big deal to you, and you have some refraction going on, in your scene, and you want it to look real, leave reflective and refractive caustics on. It's fine. It's not a big deal. It's going to take your render times down a little bit, but if it's not the main effect you're trying to focus on, you're probably not going to even notice it that much, nor is it going to really affect your rendering times by a considerable amount. It's just inconsequential, basically. If you do have a lot of refraction and reflection going on, though, it may be in your best interest to turn these things off. Cycles sucks at caustics. It just isn't very good. The way the integrator works, the integration algorithm, that's what this path tracing is. These are both algorithms for sampling images. Those integrator settings aren't very good for calculating caustics. It sucks. It gives you grainy results, and they need to add in what's called Metropolis Light Transport, I believe. It's MLT, or even photon scattering, or like irradiance caching or something. Those are other rendering algorithms that will give you better global illumination and better caustic effects for rendering scenes with lots of reflections and refractions in them. I keep saying reflections. If you can't tell, English is it's my native language, but it's so hard. Especially when you've worked 9 hours a day and you've been staring at a computer all day and you're at home making a video. Oh well. I'm gonna take a quick drink here. Oh my god. Blueberry lemonade is so refreshing. If you have never had it, it's simply blueberry lemonade. Try it. It's good. Moving on. The filter glossy setting right here basically blurs the glossy refractions and reflections that you have going on in your scene. I have it set to 0 right now, but if I go over here and I turn up your reflection strength a little bit so you can see how this is reflecting, you may not really be able to tell what's going on here, but I would turn off refractive and reflective caustics. Nothing really happens, and it just took that. Let's see here. Took that 2.2 seconds to render without them on. If I turn it back on, it still took 2.2 seconds to render. So the caustic effect really isn't, there's not much of that going on in this scene, so I don't really need to do anything with these. But the filter glossy setting will filter your glossy shading for you, and it will look a little bit blurrier on the surface of anything that's glossy. It's hard to see because it's not really that much of an effect here, but if you have a lot of refractions going on, you have multiple objects that have reflections on them and they're all reflecting off of each other, there's image-based lighting going on, there's a ground plane, you just have a bunch of extra junk in your scene. Typically you want to turn this value to 1. That is the standard filtering value, and it'll give you basically the best filtering, the best blurring of your reflections and refractions for the best return on render time. So best look or most realism for return on render time at setting 1, or just leave it off if you feel like it. From there, we're going to look at bounces. So bounces basically says how many total this max and min values say how many total bounces do you want the camera to calculate. So at minimum, you want to have this set to 0. So if there are no bounces to be calculated, if the light just fires off into the edge of the scene over here and is not bouncing off anything, the rendering engine is not going to try to return that to the camera or calculate it. So that's great. You want to keep this at 0. Max says, okay, you have a light ray that bounces into this crevice here, and then it bounces around in the crevice a little bit, and then it bounces out of the crevice and bounces to another crevice or something. That is what max bounces will account for. So the maximum amount of bounces basically says how many times this light ray that pops in here bounces around and interacts with other things in your scene. So if I was to turn this down to 1, I don't have any lights going on, so I'm not really getting any direct lighting. I'm using all image-based lighting, but you can see here in the shadow region here, If I was to turn it off, all of the light that's bouncing onto my object, all this reflected light, is no longer being calculated. So this is showing up black here. So lighting rays are hitting this piece right here that's shadowed, and it's bouncing back up into this face of the Gorgon's mesh. And because I'm not calculating any bounces, it's not returning any values. So this is showing up black. If I turn this up to 1, well, this shadow is this color, so the light that's hitting it is bouncing off onto this reflective portion and is giving me the same values and colors that are seen here. So the more bounces you have, the more accurate this sort of effect is going to be. The best value to leave it at is typically 7. 4 to 7 is where I go. If it's a really, really, really big scene, taking it down will help a lot. But I typically go to 7 for max realism, and the number 7 is cool. So after that, we have our per pass bouncing. So if we turn down our diffuse bouncing, we will no longer get any diffuse bounce lighting. If we turn down our glossy bounce lighting, it kind of had the same effect as turning down the maximum value here. You're no longer going to get any glossy bounces, so none of this is bouncing onto the edge of this material anymore. So sometimes that may be useful. I typically leave both of those settings at around 4. If it's taking a really, really long time to render and isn't coming out so great, I may turn it down to 3 and just clean up the image in the compositing window. But for the most part, 4 is a good default value for both of those. The most important settings are transmission and not transmission. I'm sorry. I typically leave transmission at 12. I forget exactly what it does off the top of my head. I think it's not doing anything here. I can't remember. I never use it. I've been using Blender for 7 years, and like I've never touched this setting, and I really don't know what it does. Blender's like that. It just has all these buttons that do things and whatever. So the most important one to, after you tone these down and get them right, if you have any refracted materials, I should say. So if I was to turn our volume on, and if I was to give this shell material here, or this shell model, if I was to give it a glass shader, I'll load in our custom glass shader so you can see this. If I was to give it this glass shader, turn on the specularity, you'll see that right now you can see straight through it into the back of this object. And it's a little grainy because glass takes a little while to calculate, but the effect is really, really cool. Glass is one of those materials that I freaking love to use in Blender. I wish it calculated a bit faster, but you sacrifice speed and calculation for awesome images. So I'm inside the glass material right here, and as you can see, light is entering from the outside and bouncing around in here, and the higher I turn up these values, the more realistic the lighting is going to get inside of this. Also, the longer it's going to take to calculate the lighting that is bouncing inside of this. So you got all these light rays coming in, bouncing off this, bouncing to here, bouncing back and reflecting off of this, bouncing back in here, all this crap. So turning these values up is great for, getting it to look realistic, but at some point you're going to be sacrificing render time. If you were to turn this all the way down to 0, that means that light is now entering into your object and is not bouncing around anymore. So it's just passing straight through. You're still getting some of this refraction. You're getting a little bit of refraction here, but the effect is much lessened because you're no longer bouncing the lighting. The inside of your refracted materials is going to look very dark. So if you have a glass material set up, you have the color up to white, or about as white as it can go. As we talked about last time, typically leave this value at like 0.998, 997, or whatever for best results. If you have that on and your material looks dark inside, it's because your volume sampling isn't high enough, or you don't have any lights that are bouncing light into your object. So if you don't have any lights, excuse me, if you don't have any lights, you're really not going to get much of a glossy effect. If you do have lights, but it's black or refraction effect, I'm sorry. If you do have lights, but it's very, very dark inside of your mesh, that is that refractive material, then your volume sampling is too low, and you need to turn it up. So we're going to turn that back up to 4 to get the most accurate results. Not much is changing here. Let me check something. Yeah, not much is changing here because I'm using image-based lighting. I don't have any ground planes on, and most of this light really isn't terminating on anything hard. It's kind of bouncing out of the frame. So there's not much to worry about here, and turning up the value isn't really going to affect anything. 4 is basically a good place to leave it. If you want to render, say, if you want to render a volume material outside of glass, and you want to render like a volume absorption or scattering node, this setting is going to be your best friend because it will drastically reduce the amount of time it takes for it to render. So I've got this glass node set up here. If I plug in a volume absorption node into the volume panel and turn the color to, say, red, it's going to absorb red now. If I turn the density up, it's going to get darker and absorb red coloring. This is how I did this image here. Let me take you back to home. That's how I did this image with some volume trickery and a glass material. Looks really cool, whatever, but that's how I got that effect with volume absorption and volume scattering. So if I was to turn this down, though, look at how black and dark it looks inside. That's because one ray is going in and is terminating inside of it. If I turn this back up, you're getting more realistic bouncing inside of here. It takes a little bit longer to render, but you're getting more realistic bouncing. Best practice, in my opinion, leave this at 0 if you're using volume absorption or volume scattering nodes. And until you start to notice the effect messing with your scene, don't turn it up because you don't really need it. It's just going to increase render times beyond what they need to be at. So if you're not noticing much of a change here between your bounce settings and your volume shading, just leave it at 0 because you obviously don't need the extra bounces. So I'm going to leave it at 4 just for default settings, so I don't have to think about it later. All that good stuff. Anyway, let's connect this bad boy back up. That is basically light path and sampling settings within the rendering engine. I know this has probably been slightly boring so far. I've tried to liven it up with some extra commentary, but rendering settings are one of those things that you just kind of want to learn once. You want to learn the best practices for them one time, and once you do, you just never have to really think about it again. It just becomes intuitive and a part of you. You can go here and click transparent, and that'll remove the background, which is great for adding in really cool stuff afterwards. Our image actually looks a lot better without the background on, adding in all that extra light. So we may comp that out in the compositor using this transparent setting. We shall see. And then down here you have your performance settings. So if you have this add-on installed called Auto Tile Size, it'll automatically calculate the correct size of the tiles that the render engine uses to sample. So you have these buckets that render in your scene. They are these right here, and it calculates light. It basically calculates everything within those buckets at one time. The size of those buckets will affect your scene, or will affect your render times. So for GPU rendering, 256 is basically the standard value. You just typically want to leave it there. If you have auto tile size, just put it on. If you're using CPU, it really just depends on your CPU. AMD cards use different values than, AMD CPUs use different values than your Intel CPUs are going to use. So auto tile size is a great add-on to handle that. It should be included in trunk and will be included with this file, I believe. So you don't necessarily have to worry about finding it. If it's not here, just go to the Blender website and you should be able to find it. But yeah, if you're using CPU, stick to around 32 or maximum of 64 by 64 bucket sizes. You want to use power of 2 values. AutoTile does this weirdly. I don't really like it the way it does that. It just throws me. So I'm going to set it to 256 by 256. But AutoTile size doesn't use power of 2 values, and it offsets X and Y. And I think it does that to better calculate it based on the aspect ratio and the dimensions of your image. But for me, I'm just going to leave it at 256, 256. Progressive Refine basically allows your rendering engine to calculate the whole image at once. So here it's calculating each bucket one at a time. It's doing all the sampling for each bucket and then moving on to the next bucket. If I turn on Progressive Refine, it's going to progressively refine. Oh, I didn't turn it on. If I turn on Progressive Refine, now it's going to progressively refine my image all at once, which is great for preview rendering, but it's super slow. It is so slow. If you're using the internal preview if you're using the preview render within the viewport, there is honestly no reason to mess with this Progressive Refine setting. Just forget about it. The only reason to put that on is if you are if you want to make sure your image just renders correctly, the whole thing all shows up. If you're trying to do that, then Progressive Refine is your friend. Other than that, it is a lot slower. Blender, it is not somewhat slower. It is 3 to 4 times slower. So yeah, wrong. Try again. Beyond that, you want to have compositing and sequencer settings checked. This will send anything you render here and output it. We'll give it a render layer node up here. So this is the image I just started rendering here, and you can see it's going right up there. If I was to turn it off, click render, and stop the render there, it is not going to send it to the compositor. So you want to have that checked. And after that, there is baking. This video is getting kind of long, so I don't want to get into baking right now. We will get into best practices of baking in a future release. I plan on covering most of the important Blender internal functions that are necessary for realistic rendering. Baking is one of them, but it is not for today's topic. Texture Atlas is also one of those settings related to baking, and we are going to leave that alone. So, with that being said, we are now going to move on to the fun part of the tutorial, compositing. And I say fun part, but compositing is one of those things that is sometimes not fun. Compositing in Blender, you use the same node-based workflow that you do for shading and texturing. However, the nodes are kind of confusing. They all do very different things, and it's sometimes it's frustrating if you don't know what you're doing. So the aim of this part of the tutorial is to give you a basic breakdown on how to take in a rendered image. So we've previewed our image here in the viewport. We've got the correct settings over here in our render panel. We've set up our materials and textures, and we've rendered an image. That rendered image comes into our node editor up here, and we are now ready to apply cool effects like glare, color correction, and all of that goodness that makes your image really, really pop. I'd want to make a quick correction / addendum to some of the information I previously presented you guys with. So before I was adjusting this volume light path node to try and reduce the amount of sample, the amount of noise, and the amount of light bounces that are going to occur basically inside of a glass material. Well, glass materials, unless you have something plugged into, I mean any material really, unless you have something plugged into this volume shading output node here, this volume setting is not going to do anything. So as you can see, I turned it up, I turned it down, it's doing nothing. However, excuse me, if I adjust the transmission setting here, transmission is the amount of light that is transmitted, basically, the amount of light that goes through an object. So volume calculates voxel data, so it basically generates a point cloud inside of an object and shades millions of little points inside of said object with whatever shading parameters you've set up in your volume material. And it calculates the light bounces within that node, or within that material itself, that shader. Transmission does the same sort of thing, but it does it for glass materials, and basically says how far the light will bounce, how many times the light will bounce around inside of the glass material, and how deep it will go inside the glass material. So if I was to turn this down to 0, you'll see it's working correctly now, and is honestly giving me a physically based result. At the center of my object, I'm getting no reflections, and at the side, I'm getting those Fresnel based, physically based reflections. So that's working correctly. But what's happening is none of the light is being transmitted through the object. 0 bounces are being calculated are being transmitted through. I've set this as 0, so if the camera, my camera here shoots a ray into this Gorgon shell, it just bounces off because I've told it not to calculate any transmission bounce lighting. As I crank this back up, as you'll see, you start getting the transmitted light inside of the object again. So that is how that works. To get a real nice close view here, turn this down to 0, no lights going in. Turn it up to 1, lights going inside. As I keep bumping this value up, it's going to keep calculating bounces inside of this material for me. So the higher the bounces are, the more realistic the lighting is and the less noise you're going to get. So you see how noisy this is down here. If I bump this up to say 10, the noise starts to clear up some more. It's really not a huge difference, but yeah, it helps. So if you're using a glass material, best practice is to start this at 1 and then bump it up until the effect is where you want it at. If you're not using glass materials, keep it at 0. You won't need it. Basically, I had it set at 12. 12. Just because my computer can handle it and it doesn't really kill my render times that much. But if your computer is a little bit lower power and you're worried about that, then just drop it down to like 4, or if you're not using it at all, take it down to 0. On top of that, I also forgot to mention these other settings up here in sampling. So the seed value here will give your integrator a different noise pattern, so it just changes up the way this noise is displayed. If you're compositing in different images that you've rendered and you want to average out the noise, do like a noise matte, a garbage matte basically, and then this seed value will help. You can render out another pass of that same image with a different set of noise samples and composite it in on top of your main pass as a matte, like a blurring garbage matte sort of thing, and it will approximate all these extra black pixels and white pixels between each other to give you a less noisy image. So that's useful if your image is super noisy, or you just want to do some general cleanup at the end of your compositing and material and node workflows and that sort of thing. Lastly, there is the clamp direct and indirect lights. So if you have a direct lighting that is just directly hitting a surface, you can clamp it, and by clicking this up a little bit, it will clamp down the amount of light that is being that is in your scene. You typically don't want to mess with the direct clamping setting. There's just it'll start messing with the amount of light in your scene, and like it messes things up. So I normally leave that at 0 because there's no point in touching it really. Clamp indirect, however, is really good for clamping these all the bounce lighting. So all these bounces here, because the renderer has to recalculate a sample each time you bounce a light or bounce a ray, it sometimes will produce fireflies, which are very, very bright pixels. Pixels where the the value, the light value is over a 1.0 rating, which is, or 1.0 value, which is technically completely white light within Blender or any linear workflow. So if you're getting really, really bright pixels in different places, I'm trying to see if I can find one. You're probably seeing one like right here. There's not really too much in this image, but best practice, if you're getting those bright fireflies, clamp Indirect and put it onto 1, and you will see most of those bright fireflies disappear. So right here, where I was getting some of those fireflies, they are now gone. If I turn this back to 0, you will start to see them a little bit right in here. Let me see if turning off Caustics fixes it. It does not. So these fireflies in here are not being caused from, or not being generated from the caustic effect. It's just simply this bounce lighting that's causing it, and clamping the indirect bounce lighting will help bring that down. So like I said, best practice, set this to 1, and you typically will not need to adjust it from there. So far this video has covered most of the rendering settings and some of the pitfalls you may run into when trying to get your renders to come out looking good and that sort of thing. So now that we've covered that, we are going to move on to compositing, but I'm going to cover that in part 3. This video is over like an hour long now, and I blabbed on enough about render settings and how to make stuff look good, that sort of thing. And if this will kind of serve as like a render setting encyclopedia for quick reference and that sort of thing. So I will just leave it as is. And in part 3, we will dive directly into the compositor and start making our image, really, really shine. And from there, we'll be able to take it to a different application if we're, say, animating. Or we can throw a still image into Photoshop and do final corrections to, make that perfect picture that you can post online and share with all your friends. So I will see you all in part 3.